Learning objectives. After studying this module, students will be able to understand presentation of data, learn about different types of presentation of data, know about textual presentation of data, learn about tabular presentation of data, know different types of tabular presentation of data, know about parts of a table, discuss geometric diagrams, explain types of bar diagrams. Presentation of data. Introduction. We have learnt so far how to collect and organize data. Generally, the data is in large volume, so it needs to be put in precise and a form which is presentable. Let us learn how to make large volume of data look more compact and presentable. Types of data presentation. There are three ways to present data: textual or descriptive presentation, tabular presentation, diagrammatic presentation. Let us discuss them one by one. Textual presentation of data. In this presentation of data, the data is described within the text. This type of data presentation is suitable when we don't have to deal with large quantity of data. Drawback of textual presentation of data. The main drawback of this presentation of data is that to comprehend data, one needs to go through the complete data. But this method helps users to emphasize on certain points of presentation. Tabular presentation of data. In this method, the data is presented in the form of rows and columns. This method organizes data for further statistical analysis and decision making. In the tabulation of data, the four types of classification of data can be done. Qualitative classification. When the data is classified as per the attributes like social status of a person, nationality, gender, etc., it is called as qualitative classification. Quantitative classification. In this method of classification, the data is classified on the basis of features which are quantitative in nature, like age, height, income of a person. Classes are formed by assigning the class limits. Temporal classification. In this classification, the time becomes the variable for classifying data. So, data is categorized as per time. Time can be in years, months, hours, or days. Spatial classification. When the classification of data is done on the basis of geographical location, then it is called as spatial classification. The location can be village, town, city, block, state, or district, etc. Tabulation of data and parts of a table. Before making a table, it is important to learn the important part of the table. The simplest way to represent data through table is to represent data in row and columns. A good table should have the following parts: table number, title, captions, row headings, body of table, source. Table number. Table number helps to distinguish between the tables. It is used for the identification of the table. A table number can be given on the top or at the beginning of the table. Title. The title of a table tells what a table contains. A title should be clear, brief, and carefully framed so that the correct interpretations are made from the table. Captions. In a table, at the top of each column, a column heading is given that defines the figures of the column. Row headings. These are also called as stubs. This is the heading of a row. The designations of the rows are also called stubs or stub items. Body of table. It holds the actual data of the table. Location of any one figure or data in the table is fixed and determined by the row and column of the table. Source. It is a statement or phrase that shows the sources of data which is presented in the table. It is usually written at the bottom of the table. Diagrammatic presentation of data. This method provides the effective and quick understanding of the actual data as compared to textual or tabular presentation of data. This method of representation of data translates highly abstract ideas into more comprehensible form. The diagrams are more effective in presenting data. Types of diagrams. The important diagrams that can be used are geometric diagram, frequency diagram, arithmetic line graph. Let us discuss these diagrams one by one. Geometric diagram. Bar diagram and pie diagram come in this category. The bar diagram are of three types: simple bar diagram, multiple bar diagram, and component bar diagrams. Bar diagram. Simple bar diagram. Bar diagram is a collection of rectangular bars which are located at equal space and are of equal width and describes each category of data. Height or length of the bar describes the magnitude of data. The lower end of the bar touches the base line such that the height of a bar starts from the 0 unit. The data for bar diagram can be of frequency or non-frequency type. In non-frequency type data, a particular feature like production, yield, population, etc. at various points of time or of different states are depicted through corresponding bars of the respective heights according to the values to construct the diagram. Bar diagrams are used both for frequency and non-frequency type variables and attributes. Discrete variables like family size, spots of a dais, grades in an examination, and attributes such as gender, religion, caste, country, etc. can be represented by bar diagrams. Types of bar diagram. Multiple bar diagram. These diagrams are used for comparing two or more than two sets of data. For example, income and expenditure or import-export for different years, etc. Component bar diagram. The component bar diagrams are also known as charts, are used to compare the sizes of different parts and also shows relationships among different parts. A component bar diagram shows the bar and its subparts into two or more components. For example, the bar might show the total population of children in the age group of 6 to 14 years. The component bar diagram are generally represented in shaded form. Pie diagram. A pie diagram is a circle whose area is proportionally divided among the components and shows as percentage to total. The circle in pie chart is divided into as many parts by drawing straight lines from the center to the circumference. Frequency diagram. Frequency diagrams represent the data that are in the form of grouped frequency distributions. These diagrams are represented by histogram, frequency polygon, frequency curve, and ogive. Histogram. A histogram is a two-dimensional diagram, consists of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class interval. The difference between the bar diagram and histogram are that the spacing and the width or the area of bars are arbitrary. A single vertical line could have served the same purpose as a bar of same width. Moreover, in histogram, no space is left between two rectangles, but in a bar diagram, some space must be left between consecutive bars. Bar diagram can be drawn for discrete and continuous variables, whereas the histogram can be drawn only for continuous variables. Types of frequency diagrams. Frequency polygon. It is a plane diagram bounded by straight lines. It contains 4 or more lines. It is an alternative to histogram, but can be fit on a histogram to study the shape of curve. The easiest method to draw a frequency polygon is to join the midpoints of the top side of the consecutive rectangles of the histogram. When we compare two or more distributions plotted on the same axis, frequency polygon is likely to be more useful since the vertical and horizontal lines of two or more distributions may coincide in a histogram. Frequency curve. This curve can be drawn with a smooth freehand curve passing through the points of the frequency polygon as closely as possible. It is not necessary that this curve pass through all the points of the frequency polygon. Ogive. It is also known as cumulative frequency curve. As there are two types of cumulative frequencies, for example, less than type and more than type, so there are two ogives for any grouped frequency distribution data. In this, cumulative frequencies along y-axis against class limits of the frequency distribution are plotted. Arithmetic line graph. It is also called as time series graph. In this graph, time is plotted against x-axis and variables along y-axis. A line graph by joining these plotted points is called arithmetic line graph. This graph helps to understand the trend, periodicity, etc. in a long-term time series data. Summary. Let us summarize what we have learned in this module. In textual presentation, the data is described within the text. This type of data presentation is suitable when we don't have to deal with large quantity of data. In tabular presentation, the data is presented in the form of rows and columns. When the data is classified as per the attributes like social status of a person, nationality, gender, etc., it is called as qualitative classification. In quantitative, the data is classified on the basis of features which are quantitative in nature, like age, height, income of a person. When the classification of data is done on the basis of geographical location, then it is called as spatial classification. A table title should be clear, brief, and carefully framed so that the correct interpretations are made from the table. Diagrammatic presentation method of data translates high abstract ideas into more comprehensible form. Bar diagram is a collection of rectangular bars which are located at equal space and are of equal width and describes each category of data. Multiple bar diagrams are used for comparing two or more than two sets of data. A pie diagram is a circle whose area is proportionally divided among the components and shows as percentage to total. Frequency diagrams represent the data that are in the form of grouped frequency distributions. A histogram is a two-dimensional diagram, consists of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class interval. Frequency polygon is a plane diagram bounded by straight lines. It contains four or more lines. It is an alternative to histogram but can be fit on a histogram to study the shape of curve. Ogive is also known as cumulative frequency curve.